Okay, let us see how we handle this one here. So it says a particle describes a simple harmonic motion in a line PQ so that after t, its displacement from P is x and d squared x dt squared is equal to negative 9x. Given that x or x0 is 4 and the x dt is 9 meters per second, find the maximum displacement of the particle from P. So in simple terms, they're asking for amplitude. So how do you get the amplitude? It means that to get amplitude, first of all, to get amplitude, the formula you can use to get amplitude is v squared equal to omega into r squared minus x squared. So we can get amplitude if we have this is our amplitude and we have this. So there we can use the after we have anything like that. So our task is to get these ones here. But now we start with the summary of the question. We are telling us that d squared x dt squared is the same as, this one is the same as x double prime, which is the same as our acceleration. So if we have that, we know that already our x prime is equal to negative omega squared times x. So if we compare now, here we have x prime equal to negative 9x. If we compare, this that this is equal to this, so our omega squared is 9, so our omega is going to be 3 radians per second. So we have now the omega. Now, we are telling us that the v, remember also that always v is equal to the x dt. When you differentiate displacement with respect to time, you get v. So now here they are telling us that the whole of this is equal to 9 meters per second. Then they are giving us a condition here. I think you can see this condition. They are telling us that x of naught is equal to 4. What does it mean? It means that when t is 0, now our x is going to be equal to 4 meters. So they want us to get the maximum displacement. So from there, as you can see, we need this, we have this, we have that. So yes, my girl. Okay, from here now, we can simply use, you see, we have now the displacement, we have this, and we have that. So we can say now from our v squared equal to omega squared into r squared minus x squared. So we have our as 9 squared equal to, this one is 3 squared into r squared minus 4 squared. So this is going to give us 81 equal to 9 into r squared minus 16. So this is going to give us 9, and bring this side, our r squared is going to be 25, and so our r is going to be 5 meters. And so the maximum displacement is that. This is our part A. That's our maximum displacement. Part B, they are telling us the position and the rest of the particle when t is equal to pi over 6 seconds. Now, from there you can use 2 formula. There now they are giving you initial, of course we have the initial conditions here. So you can either use the sine function or you can use the cosine function to get the displacement, of course. So from there, we know that we can either use x equal to r sine of omega t plus 5, or you can use x equal to r cos of omega t plus that. Any use, it will give you the answer. So what should I use? Okay, let me use this one here. So my x, now using, let me use the other one. x equaling to r cos omega t plus zeta or summation. It's up to you. Okay, now here what do I have? Now they are giving, they want me to get this displacement, but I have to first remove this constant. How am I going to remove it? I'm going to use this condition here, the initial condition. X of naught is equal to 4, implying that when t is 0, this one is, we start here, displacement is a function of time. I think you see. That's why this means t, then x will be 4. So putting where we have 4 equaling to our r, which is 5, then cos of this is going to be omega 0 plus this. So it's that I have 4 over 5 equaling to cos of this. Putting it to the calculator, I have now this. Now here your calculator should be in the radians, Okay. 5 by 4 cos inverse of that. I'm getting 0.6 to 4 decimal places. 5. So meaning from there, my x is now r cos t plus 0.6435. So now I need to get the displacement. To get a displacement, the position, that's where the position will be here. So what after what? So when t is 5 over 6, now we can get our displacement. So this is going to be 5 cos. Now our omega is 3, then 5 over 6, then plus 0.6435. So when I put this on the calculator, I'm going to be, this is going to be pi divided by 2, then plus 0.6435. Sorry. This is plus. Okay. Then cos of the answer, then times 5. You see the answer I'm getting is negative 2.99999. Which when I'm rounding off, I'm going to get negative 3. So this one means, whenever I say negative, it means that the particle was below the equilibrium position. So, therefore, magnitude of this equal to magnitude of 3. And so our x is going to be 3 meters. So when you have x, now this is the position where the position is going to be 3 meters from, okay, you say, okay, particle will be 3 meters below. Why am I saying below? Because of that negative. Using this, if you use cos, you get negative. Below the equilibrium position. Okay. Now from there, after getting that, now we can only get our, of course I have now this, so I can only, because I want to get the velocity, so I can use this because I have. So the displacement here will give me the velocity at that point. So now, my v squared equaling to omega squared, r squared minus x squared. So here I need this. It's going to be this is 3 squared into now this is 5 squared minus 3 squared. From here, my v is going to be, this is going to be what? This is 25 minus 9, that's 16 times 9. I get 144. And so here my velocity is going to be 12 meters per second. And simple. As simple as that. So if you want, now you can, this one also going to give you the same answer. Now, alternatively, if you don't want to use the method, this formula, now you can come back here, from here, and you have your x. After getting your x, and then from here, now you can get from here, our x is r cos wt plus 0.6435. If you have displacement, to get velocity with differentiate displacement. So see that now, my x prime, if you differentiate this, it shall be having negative r omega. You differentiate the angle, you differentiate the angle, you get this, the remove right here. And differentiate because you get a negative of sine, now omega, then plus 0.6435. So now this will be equal to r velocity. I think you remember. Alright, which will be equal to x prime. So now my velocity is going to be, we have this as negative 5 times 3, then sine of 3 times pi over 6, then plus 0.6435. So it's that from here, we are going to get a negative. It's going to be pi divided by 2 plus 0.6435 sine answer times 15. So you see, I'm getting the negative from 0.00000 meters per second. And if you get the magnitude of this, that RB is going to give you 12 meters per second. This is mathematics. Any method you use, it's going to give you the answer you want. Alternatively, and after getting the same answer, of course we are happy. We are happy. We are happy after getting the same answer. Very happy. So either use this approach or you differentiate. But now I would suggest to use this one. Because people, when they are differentiating here, most cases they forget to get this coefficient to multiply it here. And then there, you will never recover. So that's it. Now, if you use sine and you use this method here, you get something. And of course, when you round off, you'll be also again 12. So either use this or that. The answer is going to be the same. So that's it. I wish you well.